because we want to make sure we have enough time. So, let's see, what does it say my name is here on this? My name is Mike Kendall, and I head up the worldwide business organization for our infrastructure business in ISS, as well as all of our options business as well. And so that's all the fun things you get to put in servers, like memory, hard drives. You could also do different kinds of racks and power systems and things like that. So here to talk a little bit about one of the pillars of the Gen 8 announcement. Let's go ahead and be interactive and ask questions, because I really like that a lot, going down different. And we got a decent amount of time. I've got a live demo that I hope will actually work to show you some of this stuff, as well as some toys here we can show and pass around as well. So just let me know if you have any questions and we'll dig on in. Yes, Mike? Oh. No? Okay. I'm just going to jump right here, because you guys all know a lot of the basic challenges a lot of our customers are facing, which is how do I deal with all the big demands of increasing workloads and increasing storage and the need to do more, but fit that either into certain limited amounts of space, or the amount of power you have, or amount of cooling envelope you have, because all those things are physics, and they require a fair amount of money to expand. Either building more space or bringing in more power feeds or finding a way to cool more efficiently. All those things are fairly capital intensive for our customers. So one of the things we did as part of the whole Gen 8 thing, and what I'd like to tell people about the whole kind of philosophy behind Gen 8 as a kind of overriding philosophy, is the idea that silicon-based intelligence is widespread and cheap to put in. So why not make things smarter? And if we can make stuff smarter, then can we also have that apply not only to how long does it take for you to set the machine up, and how well do you manage it, and how well does it perform, but can you also positively impact the power that it uses, the amount of cooling that's required, the amount of space that it takes up to give you a certain workload there. So this was also part of the work that we did. When you see some of the numbers we did, the amount of time we spent on this particular product line here, that was a big part of it, was to how do we address issues around the environmentals. And so that's what we did. So we actually came up with some really cool ideas. One of them was not this. So I'll just start out and say right now that this is a conceptual drawing. You can't buy this product yet, but that's the direction we're going from a visualization standpoint. The main reason it's in here, are the cameras rolling? Is that executive management really likes that picture rather than the current 2D versions that are available in the product. So that's why that's there. But that does give you an idea of where we're heading around visualization. Imagine if your software was smart enough to visualize location automatically, temperature automatically, power levels automatically, workload automatically, and then be able to act on that data and be able to give you a zoom and zoom out type capability. That's where we're going, but we have a lot of that foundation that we came out with Gen 8. So everything I talked about around being able to automatically discover locations of a server, being able to know its power load, being able to know how it's wired up, what kind of workload there is, and how hard it's exercising the subsystems. All that stuff, or things that we either enhanced in Generation 8 or are brand new in Gen 8. And then we've also made things more power efficient as well. So that's another thing. With power efficiency, the whole idea is how do we take the power that comes into the building and then ultimately gets delivered as the workload at the server, how do we go ahead and make the losses that occur along that chain as small as possible? And one of the things you got to do is you got to make each little step as efficient as possible, because we're already from end to end around 83%. And so we're not going to go ahead and add 25% or 30% more efficiency, at least if you went to the same thermal and fluid mechanics classes I did that indicated that you can't break the first and second law of thermodynamics, at least not yet. So every little amount of power efficiency we can get. So like making power supplies more efficient, being more efficient with the way that we cool things inside the server. These are all things that we worked on in Gen 8. Okay, questions? Oh, if I move around a lot, does that cause a problem with the camera there? Or Am I supposed to stay right here?
That's good. You've got 2 cameras on you. So
Oh, okay. Cool. I just didn't know the setup.
Just start jump around.
Okay, yeah, I'll try not
Stay
to.
stay to that side, but, you know, I can move.
Okay, because I have a tendency to walk around.
I'll walk
I'm
around.
kind of like really, got a lot of energy. Okay. All right.
We'll
So,
chain you down.
huh?
We'll chain you down.
Either that or just, you know, a taser or tranquilizer dart, and my family will probably thank you.
Okay.
All right, so some of the innovations that we made here in the Gen 8 part of that launch there was, first of all, and this is one that we think is really cool, and we'll give you a little bit of a demo of this as well and show you how this works right here, is around what we call location-based intelligence. And we say that this is both in the server and in the rack, and I'll show you how that's true. But we've done some things around this here, because one of the things we found is when you're trying to figure out how to place workloads and how to manage workloads and how to manage your power and cooling budgets that you have within a data center, one thing that's really important is where's the server? And so one of the things that we kind of worked on for about a good 18 months was how to do that in a way that is extremely reliable, but also doesn't give off radio waves, because it turns out we have a whole set of customers who don't like the idea of servers broadcasting where they are. And so we tried a whole bunch of different approaches. We looked at what some other people did. We came up with what we think is a pretty cool and unique approach that we'll talk a little bit more about. And the other thing about this is not only does it give you that information, but it also takes out a lot of errors around asset tracking, the amount of time it takes to do asset tracking. If you've ever been lucky enough to either sit there and try to write information off a toe tag and put it into a spreadsheet, you'll appreciate this. The other thing we did too is expand the concept of our intelligent power distribution. So we have an intelligent PDU. I'll talk a little bit more about that. We've expanded what it does. We've expanded that line. We've expanded the kinds of platforms it works with and how we're integrating that into the entire kind of management platform. So talk a little bit more about that. But this is a capability right here to know how systems are wired up, what kind of power they're using, be able to provide that information on a real-time basis for folks that are managing their environment. And the third area is how we became more efficient and how we were able to understand what's going on temperature-wise at a very precise level within the server. Any questions so far? Checking email?
Listening intently.
Okay. So one of the foundations we started with was the rack. Now, racks to a lot of folks are just racks. And they can be either very pedestrian, very pedantic, but we actually spend a fair amount of time and money thinking about racks, and there's a couple of reasons. There's 2 key elements of racks really important. One is airflow. And so one of the things, and the reason airflow is important is to be able to cool the equipment inside there. And therefore, the more efficient you can make the airflow through the rack, the less power it takes on the fans and the less hard it is on the equipment within the rack, and the lower power you can use on your air handling equipment within the data center to cool that. So we actually have these doors that we design looking at the shapes, and we test them in wind tunnels. So I'll tell you one little story. I guess at this point you've had a chance to see our nice industrial design for the Gen 8 with that nice hole pattern that we have. Really cool. What we wanted to do the same thing for the rack, and we had the same design agency work with us on the rack, and when it came out, it was beautiful. It had like that pattern in the door. There were 2 problems with it. One, it was really pricey because it included compound curves and a lot of punching. The second thing is it cut the airflow it cut it less than half of what it needed to be. And so even though it looked really nice, we decided not to go with it. So we're back to this very translucent view here. This is not as high res as you'd like, but if you just look at the rack and kind of put it sideways, it'll be the color of Jack Black, the new official color that we have. But when you turn it and there's nothing in it this way, you can see straight through it. And then you can see how translucent it looks like here, because that whole pattern right there is about 25% more open, and therefore better than any of our competitors' racks are. And that just makes it easier to pump air through this. So that's one of the things we spend time on. The second thing that's really important is how much load these can take. Now we have customers who ask us to load these devices, these racks up before we ever ship them to them. So we have a factory over here, Factory Express, CCM6, and other places around the world, where we actually go ahead and put all the systems in, wire it up, put in the software, and you can get up in like a 47U rack close to 3,000 pounds of equipment. Think about that. That's like a small to low-end mid-sized car that's fitting in one of those. And so we actually test them that you're able to ship them with this amount of load in it. And if you actually go online, we have some videos where we're actually showing where we drop it from about 1.5 foot up, fully loaded, to see what kind of deformation occurs to the rails and to the base. And so that's really important for us. And we also have our value-added resellers who like to integrate these things and ship them out whole. So we spend a lot of time on actually trying to see how these things hold up in various types of weird shipping situations. So one of the ones we have to do is I didn't know about this part, got into this part of the business, but like the ability to make a rack that you can have loaded and shipped flat. And the reason you need to ship it flat is because if you stand it vertically, it can only go on like 747 class air freight if you're going to air freight it. If it's a 767 or a 757, it's got to lie flat. And so we have to think about that too. And we've had some interesting failures in those tests. So, because it's a lot harder to make it so it doesn't, do this type of thing in the box. So, the other thing we've done too around this is make the rack, as I said, intelligent by the way that we put in instrumentation in the rack to help find the location as well. So we'll have a chance to talk a little bit more about that and how it hosts that and how it hosts the intelligent PDUs and how it's well set up for that as well to create effectively what the foundation of an enclosure operating at this level. So we've taken a lot of the things we've learned about at the blade system level, how to build a smart kind of enclosure, and now we're incorporating it at the rack. So now you can tell all your friends and everything that the racks are actually more interesting than they first appear. Any questions? Okay.
Lots of tweets going though. That's
Okay, good.
good. They're paying attention.
Good, good. I just hope they're tweeting something good to check it. So you'll see a number that's been bandied around, that 70% more compute per watt. So where do we get that number from? So what we did is we ran a good set of both industry standard and then typical workloads on the server. So database applications, exchange type applications, web type applications, ran a good mix of applications. At minimum, we're generally running on average for a blended set of applications 65% to 70% faster for a given workload, higher throughput than a similarly configured ProLiant G6 server. The other thing we did is we found a way to take for pretty much an equivalent configuration and to reduce the actual power levels required to do it by about 10%. So we had a big jump between the G4, G5 versus the G6 and the G7. A lot of big changes in the topology right there. As you know, as you get higher up that curve, now you got to start, fighting a lot harder for each amount. So we got about 10% more. So if you take like 65 divided by 10, you get 73%. So roughly, so we conservatively say 70%. That's where we get that. Here's the way we did that. We did that first of all by taking our CS sensor technology. Are most of you familiar with CS? Did they talk about CS sensors already? Okay, they talked about that. And they tell you already how we got it into, we found there was that area that we didn't have them in very well, which was over in the I/O and the riser card area. Okay, I'm seeing nods and everything like that. So just because we have additional coverage, or we were able to get additional efficiency out of that. So we have well over, on average, anywhere between 32 and 60-ish sensors now, depending upon any I/O cards that are put in there for CS sensors. That helps take several additional watts out per server on an average basis there. The next thing are Platinum Plus power supplies. So I'm going to walk over here for a second. Are you guys familiar with the 80 Plus certification group? For those that may not be, there's a power supply certification group. It's called 80 Plus, and they actually lay down the rules of what power supplies conversion efficiencies are, as well as total harmonic distortion, power factor correction things, all things that can impact the efficiency and the amount of power you can actually extract from a given circuit. And so one of the areas that we're very, very happy with is, first of all, that we have these common slot power supplies. So the vast majority of our ProLiant servers and a good number of other products around our infrastructure business here now use these common slot power supplies. So they're all the same basic basic size here, same size, same shape. So you can get them at different power levels, 460, 750, 1200, and you can also get them at different efficiencies. But for the vast majority of our Proliant Gen 8 line, and particularly the P series, the vast majority of them will come standard with 94% efficient power supplies, and that's the highest in the industry that comes standard. And all the rest of them can be upgraded to 94% optionally. There's some we have at 92% because we're trying to hit some cost points as they come standardly out of the order system, but you can upgrade them as well. What that means is that a 50% load, that you look at an efficiency curve, these are able to convert, you put in 100 watts, you get 94 out the backside here that goes actually to the server. Now there's several ways you can identify a 94% power supply from HP, and that's, first of all, it says 94% there. That's one way you can tell. The second thing is all of our 94% power supplies, and they're called Platinum by 80 plus, has this blue connector on there, and I'll explain a little bit more about what the significance of the blue connector is in a couple of minutes, but that's the fastest visual identifier is looking at that. The other thing too is we have a minus 48 volt version of this. That's really important for our telecom customers, and we're playing around with other versions as well. We're playing around with 277 volt because that's good for some of the folks that are doing a lot of very large type implementations. And there's also some stuff going on in the industry around 380 volt DC, and we're doing some playing around with that. But we're able to do that and not have to change the servers because we have the common slot design here. So that's another area. The other thing is HP Smart Memory. Did they talk to you about HP Smart Memory already? Mm-hmm. Okay. All right. Cool. And then and we're able to run like as faster at lower power. So there's the secret there. And then all our servers are enabled for location. I should actually say power discovery services. All right, location discovery. Oh, this is where we get to do a demo here. Let me just take a quick look, see how far we go ahead. Okay, so I'll talk about this a little bit. So what we did is the secret to all this, and we finally came down, is how do you get a server to identify where it is? There's two things. We decided to have use a technology called one wire. And there's two parts. This part goes in the front left retina rail of the rack. So you're standing facing the rack. It's over there. There. And you see where it's actually located in there. And on each one of these, for each U location, are two contacts. And on the back side, there's a chip there, which is effectively an EEPROM that has the rack identification number and the U location. And then on the server, look at the front left ear here. There are these two connectors right here. And those go off to a little wire right there. And that then goes over to a one-wire chip here, which then converts that to an I2C bus connection to the ILO. That means when the ILO sees that's connected up right there, it's able to effectively query this connection right here to get that information and make that part of the server profile. So at the server level, that's how the server ends up knowing. So this just slides in, makes contact right there. That's how the server knows where it is. Now what do we do with that information? They can be passed on then to SIM. Excuse me. That can be passed on to SIM and to inside control, and what it will do is populate effectively a rack image like this right here and actually show you the location and the server. Plus, you can dive into the individual server and get that information. I'll actually demonstrate that for you. I don't have this picture up yet because they're still doing some changes on the software for that, but we will have a demonstration of that at HP Discover, which is in Las Vegas in the first part of June. So that'll be live right there, but I will go on live and actually show you, log into a server we have over in our actual lab where we're working on this and show you how we actually get that information there. Okay, so before we go into power discovery, let's actually see if I can get this to work.
So how does that little bus bar actually attach to the rack?
It actually will snap in. Right now the prototype holds with screws right there, but what there is there's right in front of the retina rail right there, there is a bracket that we have where these click in. And by the way, we make those in 7 and 8U sizes. So that's how you get the combination to work out, to make them in replaceable strips for field service and other types of activity. So to work in the different combinations of 36U and 42U, 47U, et cetera. That's how we get that to work out. This combination of 7 and 8. And plus they can also be programmed in the field.
So is it just a bracket that then hooks into like the top and bottom U point, or how does that hook to the rack?
Come back here. So there's the retina rail. I'll try to blow this up for you, because I don't have it. Yeah, obviously I don't have a rack here
Right.
for you. And so what there is there's attached at multiple points, actually off the retina rail right here. There's actually a bracket, top and bottom, middle, roughly. And there's a bracket that then is in there, and then these snap into that bracket.
Okay.
So it's an optional thing. So you can buy a rack without this, but you can also go ahead and buy it either ready for it and then it's retrofittable in the field, or get it integrated for you at the factory.
But that bracket doesn't just hook into like a standard U spot. It specifically hooks into a special spot on these racks.
Yes, it does. Correct. So currently this only works on an HP
On the new HP
intelligent,
rack.
the new HP rack. Yeah, it doesn't work on the G2. It's not that people haven't thought about how you would do that, or to work with a Chatsworth rack, but currently it's been tested and works well this way. So operators are standing by. Okay, let's see if I can pull up the actual demo here. This won't be all that exciting, but okay, let's just go ahead and expand this out. So this is actually live, not Memorex. So that means hopefully it'll work. Okay. So I can go right down here, information off of ILO 4 to location discovery services. So there's a rack actually with us in here. And so you see what we've added right here. First of all, is there discovery rack support? And it'll tell you yes it does right here. There's the rack identifier. It'll tell you the rack kind and what its product description is. Right here, you can look in here, and then it'll give you the rack U height, U location, the position right here, along with the server U height and everything. So it'll go ahead and give you all that information there. That's additional information when you actually dig into here. Now, what I'd love to show you, but as I said, we're making updates to the software, is how that then actually automatically populates within Insight Control. But you can see where the information comes in, that Insight Control then goes ahead and pulls together and figures out where the server is. The one that we haven't figured out is how to have the data center figure out where the rack is. It's a lot harder. It's because the rack knows what's inside it. It doesn't know where it is.
I just link it to the adaptive vent tiles.
That's our next product idea. No, that would be, yeah. I mean, we actually had some crazy ideas about. Well, what if? Okay, you can't do GPS. What about lasers? No, lasers, bad idea.
Yeah, somebody walks through. Oops, you just turned off the cooling.
Yeah, right. Yeah, we've had some interesting ideas. We've been playing around on that, but not ready for prime time yet. But some interesting ideas. All right. How am I doing in time? Pretty good. Okay. Power discovery services. So if you're familiar with our intelligent power discovery units, we actually have come up. See if I can. Let me go over to a picture right here. I don't have a picture of it. Okay. This is how it kind of goes together. So what we did is we took the idea of a PDU, and we added to it intelligence in the form of microprocessor, system on a chip, all that other good stuff, and made it so that it's able to infer a bunch of things about the way it's connected up in the rack and connected to other intelligent power distribution units in the rack. And so, like for instance, if I put, say, like 4 units in it, and these units come in different shapes and sizes. And if I go ahead and put them in and wire them up, let's say on an A feed and a B feed, and I have these communicating, they actually figure out that I'm on an A feed and a B feed, and I'm also redundant because there are other ones there's another one on the A feed and another one on the B feed as well. So at that point, they automatically discover the power topology that's coming into the rack. And then from there, they infer that if you're actually hooked up redundantly, you want to hook the servers up redundantly as well. Because what you want to do is make sure that if you have redundant power supplies and redundant power setup in your rack, that you've actually hooked the A side power supplies to the A feed and the B side power supplies to the B feed. And you may laugh, but people mess this up. And then, you know, if you go ahead and shut down the A feed to do some work on it, then you see all of a sudden the lights go down out on several racks. You realize, you know, as we like to say around here, imitating Scooby-Doo, rut-row. So that's one of the things we did. So one of the things you'll hear us say that we just love blue plugs. Because the blue plugs, one, have a good margin on them, but also have a data connection in them right there. So there's the data connection right there. Data connection inside there. And if you look at the reason I said the blue plugs are important on the power supplies, is there's a data connection there. That is a data connection that goes through the power supply and then makes a connection once again to ILO. So now we're able to look at what is the configuration of the power supplies in a given server, understand the server's information. If it's got location discovery services, now the system now knows also the location of the servers, can correlate that to what sticks it's plugged into and how it's configured to the PDU. Now you start getting a whole bunch of information you can correlate. So you've got the ILO talking to the system. You have the system here knows exactly what power it's drawing at all times. That's another thing the PDU knows, is the power. Can correlate that with what the states are in the server and what the server says it's pulling to make sure everything's accurate. That gets commuted off of this plug here, which then goes over and hooks into these sticks. So these sticks go up and down the back of the rack. So if you look at one of these fully configured, you'll see a whole bunch of these. Does this one have the really cute thing we did? Oh, the other thing when we came up with the first version of this, it's simple things that solve a lot of problems, is the numbers which identified the sockets were upside down, and we didn't want to come up with extra parts, so we just kind of made it so that when you flip it over, they flip over, and the numbering works so that we can have the same parts for the left and the right side of the back of the rack. But then this goes down. This has, once again, communication lines into it that hook down into the actual main PDU core units.
Now, is this also designed just for HP racks, or can it also go into a third-party rack?
It will go into anybody's third-party rack because it's a pretty standard 0U mounting on the cores, and then these mount behind the Retma rails in a standard way as well. So they can go into anybody's there. And then the other thing too is this will also work pretty well with non-HP equipment. And the way it works there is it will basically say, look, I've detected the load. The load is pulling this much power. It looks like it's hooked up to the same, so it can't tell if it's a redundant hookup automatically because it can't query and say, who are you? And it gets an answer back on both sides. It just gets a load that's, oh, they're both on the third unit up, number 2 outlet right here. I'm going to infer, at least initially, that this is the same load. They're both unknown, and then it will provide you, within the interface of the IPDU or up into Insight Control, the ability to manually put that information in. So you can say, well, this is a Cisco switch that's sitting up there, some type of catalyst or a Nexus switch that's sitting up there, and you can go ahead and put that information in, or maybe it's some other type of storage you have in there, or even alternative company's service. So it'll work with that as well, and you put the information in. It'll still go ahead and track the power. You can still make sure that if you have a certain feed going into the rack, so you're limited to so many amps that are going in the rack, and that is equivalent to plugging in so many units, and therefore you're coming close to that, and these top 2 plugs are inactive. Doesn't matter if it's an HP product or third-party product, they will not go in unless someone manually switches them on. So once again, you avoid someone going in and putting in a server and wiring it up and plugging it in and then blowing the circuits, because it knows that it's near the limit right there, and it takes a lot of manual override to do that.
Will
So-
it graph and trend, like, will it show me that power
Yes,
graphically at all?
yes, it will. Yeah, and then you can go into Insight Control and actually look at the trends longer term.
And how
Min,
much-
max.
How much overhead cost-wise is there for these cables versus standard power cable?
Oh man, you can't believe it. But they're worth every penny. No, this is going to run you about 25-30% more than if you just went with a monitor PDU with standard cables.
Do they come in different lengths?
Yes, they do. They come in all sorts of different lengths and slightly different configurations because these are like the C14s here. You get C9. So you get C9, you get C19s as well, and directly go off the cores. In fact, we came out with a unit that actually has dual 6 plugs on it, and the reason we did that specifically was for C-Class. And that's another thing we did when we announced all this in February, is we announced that C-Class can now participate in power discovery services. So there's a new Medusa unit that's in the back there, and you can identify it because it's actually got connectors that connect between it and the onboard administrators, and that way the actual power strip can monitor the power going in and out, but it can also then talk to the onboard administrators and get all the system information to provide it down to the IPDU. And so, folks there don't want to hook off of these. They want to hook off the bigger ones, and they can just plug directly off of the unit that's got two sets of 6 plugs on it. Hook it up. And so you'd have one for two C-Class chassis, and the other side would be the redundant for the C-Class chassis there. That's how you'd hook that up. All right. Any questions on that? All right. And this is how it basically hooks up here. See, where did I? And by the way, that little picture right there, that's actually a clip out of a display in Insight Control. What it would actually look like right there. So it's going to show how things are hooked up here. It's showing the feeds right here. It will show, here's the cores right here and the connection off the core units, and then off the sticks right here, and how they're actually wired up and where they're wired up to. So that's the kind of display you get. And I was going to show you, but for some reason I think the system's down because I can't get to it. I tried it this morning. But we actually have one that actually shows what happens if you just wire things up cattywampus. And what it shows literally is not these nice little straight lines right here, but it shows the lines all crisscrossing all over each other. It shows a really bad wiring job. I wanted to show that one to you, but I just couldn't get it working this morning. All right, this is not the 3D view, but this is effectively how that readout occurs here, where, for instance, you're able to show kind of correlated cooling information right here, and so you can see by basically the colors the different types of temperature gradients that are going on at a rack level, how they're basically wired up, what's going on in a row. By the way, the reason it knows the row here is because you have to tell, you can actually program in here, this particular rack is this one right here, let's say. And so it'll kind of show you an aggregate level of temperature right here. You can obviously correlate this to what's going on then with your computer room air conditioning and air handling systems. And that's how, if you get this, so you can get displays around this, you can get displays around power, you can get displays around location right here, you can get displays around what the CPU is doing and what the memory subsystems are doing, and begin to correlate all of that, particularly if you then plug that into things such as the vCenter for Insight Control, and begin to correlate the types of data you have to make smart decisions about where you want to place workloads and where you may have capacity for bringing on additional workloads as well, from once again, from a space, power, temperature standpoint there. So that's really what we've kind of brought with Gen 8 in this area. Do I have anything else? That's just, all right. So I'm going to go ahead and open it up for questions. I mean, at a high level, that's what we've done here, and that's our quick little show and tell that we have. Do you have any additional questions from the environmental standpoint, what we've done here?
When do we get adaptive vent tiles?
I don't know. That's a good idea, though.
Well, they've had them in the sandbox. I was out in Fort Collins.
Oh, the
last
Fort
year.
Collins things, yeah.
I keep watching and going, when are we getting these? When are we getting these? Because those plus this, it seems like is match made in heaven.
Yeah, I think we got to, those guys are really smart. We're the ones that have to figure out how to commercialize them, make them money, and manufacture them in large quantities, so they don't do terrible things. And we get lots of service calls and angry phone calls. But that's an interesting idea. The other thing too is, once again, when you look at a pod type of thing, you've got a lot more end-to-end control. So the ability to do this. So we're doing some interesting things also at the pod level. But I know we actually so maybe this will come up because I know we have a discussion internally, and the HP Lab folks are going to be talking to us day after tomorrow about their latest stuff in the Fort Collins lab there.
Sandbox has some really neat stuff, and they were talking about the sea of sensors, and this was before Gen8 had been announced, and they were very excited about the sea of sensors and kind of coy about what was coming up on the PC side, rather the server side. So, is that going to become like all tied together with the into one simple interface as far as Insight and the Insight part here, and like the sea of sensors they had in the sandbox back there with the individually cabled sensors as well?
Yeah, so we're looking at the best way to do that. I mean, we have sold some third-party products that are like sensors that actually get mounted in racks and on racks in different parts of the data center there. And so we're looking at the best way to really do that. I mean, there's no real standards on how you hook these things all up and make them all run. So it's just now all of a sudden you have to start writing interfaces for all that stuff. So once again, it's how do you just like create an open interface and let third-party stuff rip and roar, or are we going to package it up and sell it? Do we have the guys do we have sufficient staffing in the field to help people figure out how to sell it and install it so they get the most amount of benefits? So yeah, the answer is you're seeing a great increase in the interest around how do we make the infrastructure more intelligent and more capable. How we commercialize and go to market with the right support and everything is still a lot of work, and then with the right software, is where there's a lot of work that still needs to be done on that. But yeah, so we're looking at all that stuff. The floor tile stuff is an interesting idea that I think we'll be discussing with them over the next couple of days here. And I always love a trip to Fort Collins. It's where I'm going this weekend because my daughter's graduating from Colorado State University.
Congratulations to her.
Yeah, it's the last one. I've made my last tuition payment. Last birdie, last tuition payment.
How many did you put through?
2.
Okay.
And one went to private college, one went to out of state.
Okay.
Yes, that was a slight decrease in the amount of reserves right there I took.